You guys survived the 13th. That's nice. Anybody see the harvest moon on the 13th? Yeah? No? You guys, are you guys all right? Are you guys recovering? Okay. I had a good time Friday. Drank a lot, looked at the moon. Lit a fire in the backyard. Didn't burn anything down. It's great. So let me see what you guys know about probability already. I think we talked about the situation, the let's make a deal, the doors. Did we talk about that? No? Okay. I love you guys. You guys look, well, you're here. It's good. So, real quick. The original let's make a deal. You sure we didn't talk about this? The doors to pick one. There's goats. Goats. Okay. Anybody ever heard of the game show Let's Make a Deal? Okay, I don't think it's Wayne Brady now, or is it still Wayne Brady? I have no idea. It used to be Monty Hall, like 3.2 million years ago. And what they did at the end of the show was the top winners had a chance to come pick a door. Behind two of these doors were goats. And I'm assuming the people that come on the show weren't hoping to get a goat, right? So that would be a bad price. So behind two of these doors are a goat, and behind one of them is like $25,000 or a trip to Aruba or whatever. You with me? So one door's good, the other two doors, not so much. Somebody pick a door. Oh man. 1, 2, or 3? 3? Okay. So I had earlier picked which door to have the prize behind in my head. You just got to trust me, too bad. Well, now here's where things get interesting. What's the probability that whoever said 3 picked the prize door? A third. One prize door out of 3. So she had one chance, I think it was she that said, one chance out of 3 to get the right one. So the probability she won already is 1 out of 3. So what's the probability she lost? 2 out of 3. Okay, that's amazing. Because there's 2 doors out of 3 that have things that she doesn't want. I'm assuming. I don't know. Might want a goat. Well, goats, milk, cheese. I don't know. Here's the twist. I'm going to open up another door and show you a goat. So I'm going to open up door number 1 and show you there's a goat behind there. This spider goat, spider does whatever spider goat does. So I open up door number 1. Door number 1 is now open, and I show you there's a goat there. And then I ask you, do you want to switch doors? One-third of the time, you would have picked the right door, correct? 2/3 of the time, you are wrong. Why did I open this door? What's more likely? Why didn't I open that door? So, again, what am I thinking? I'm not going to open up the door with the prize, am I? Because then that's the end of the show. You know you got a goat. There's no drama. So when you pick a door, I'm going to open up a door that has a goat behind it. Stay with me now. You guys with me? So, how many times will I open up a door because the other door has the prize? 2 out of 3 times. Because what's the probability that you didn't pick the right door? 2/3. Let me make it like this. You ready? Let's say we have this insane show where there are 100 freaking doors. 100 doors. And you pick the 4th one. You with me? And I open every door except this one to show you a goat. Can you now see what you should do? Most likely, why did I not open this door? Because it has the frickin' prize. What probability did you have to pick the right door in the first place? 1 out of 100. So I am not going to open the prize door. What's the chances? Why? Either the prize is here, or you picked it right in the first place. Which one's more likely? Prize is frickin' here. So if you switch doors, you have twice the probability of winning. I didn't just say that you will win. I said you have twice the chances that you will win. Anybody ever watch the show Mythbusters? They did a whole show about this back in the day when it was Jamie and Adam and all the other people. I don't know who's doing it now. Are they making new ones? I have no idea. Who knows? All right, I'll stop. Some of you guys are like, what the shit are you talking about? All right, I'll stop. All right. Your brain tells you have a 50-50 shot. Your brain is wrong because I gave you more information. So it's a higher chance this door has the prize. Now in reality, this door had the prize. And this one had a goat. But that specific instant doesn't mean shit. Okay, so you would have won if you would have switched. All right. Hopefully this helped make some sense. Yes?
So why is the probability higher if you get more information? I mean, I get, like, I feel like I'm getting it, but I'm not.
All right.
And instead of, I think my question is why would it not be 50% if it's only out?
So let's say in a bag there's 100 marbles. 99 of them are green, and one of them is white. And then you pick a marble and don't look at it. And I pour out all the marbles except one, and they're all green. So either you just happened to pick the white marble in the first place, or I purposefully left the white marble in the bag. Which one's more likely? You didn't pick the damn. It was only a 1 out of 100 chance. There's a 99 out of 100 chance it's in the bag. So really, here's the whole thing. There's a 1 out of 100 chance you picked the right door in that second get up, right? Because when there's more doors, it kind of is easier for your brain to latch onto. So there's a 99 out of 100 chance that it's not that door. I open up 98 of the doors. There's still a 99 out of 100 chance that it's not your door. So if I open up 98, then change. Holy shit, it's going to be that other freaking door. What probability, how often will you not win if you do that? 1% of the time. Right? Which doesn't mean it would never happen. You with me? Yes, maybe. So if there's a 0.0003% chance that we'll be hit by an asteroid that will kill us all, that makes me feel better and worse at the same time. Better because it's so small, worse because it's not zero, right? Okay, maybe. But, all right, even if this still doesn't quite make a ton of sense, you're never going to have to figure out something like that on your own. Are you with me? This is a really good illustration of how our brains are not hardwired for probability. They aren't. And that's why people in the news, and people in politics, and people in the stores and shit, they take advantage of that so much because they know these people don't know this shit. So a lot of time when you hear people talking about probabilities, they're probably using them wrong and probably on purpose. Okay, because it's easy for humans to get deceived because we don't know probabilities inherently in our heads. We don't. We're not geared for that. All right. So let's kind of take it down to something we can handle, right? Because that one, I'm going to admit to you, again, that's not an easy thing. A ton of people across the U.S. never understood that situation, and I'm not saying you should immediately understand it. But really the purpose of that was, like I said, to show you that probability is not inherent. What kind of probability do we have in our heads is survival. All right, it's 5 o'clock. If I go this way, saber-tooth tigers are eating this way. More than likely. And this way, more than likely, I'm going to go this way then. We understand that level of probability. It's 3:30. I live there. I'm going to sit here because there's a high chance there'll be a lot of traffic. I'm just going to wait. Living in this area, we've all done that calculation, right? Yes? You almost, I lost my window of opportunity. I know that feeling. Listen, we're just going to hang out here for 3 hours and then wait for this traffic to die down because I suck in traffic. Okay, so let's do the basic thing first. Let's make it more interesting than poker chips. Let's say I have 4 Butterfinger, 5 Snickers, and 7, what you got, Jeff? Ooh, Rocky Road. You know the Rocky Road? Anybody know this? There's a Rocky Road candy bar. Anyway, bit chubby. Everybody knows, you probably know what's coming. What kind of probability question would I ask you? I pick out one piece of candy. What's the probability it's Snickers, right? So what is the probability I get a Snickers bar? And here's the notation. How do I read this? The probability I get a Snickers. One thing math people are really good at is condensing phrases, right? Because a lot of us can't write well, evidence, right? And also we just have a lot of shit to do with our lives. We want to get this over with. So we want to have symbols that represent ideas. And then the rest of us have to learn those symbols so we all speak the same language. So this is probability of S, and S is Snickers. So what is the probability I get a Snickers bar if I reach in and grab the bar? 5 Snickers out of 16. Yeah, there's 16. So 5 chances to get what I want out of 16 things that could have happened. Let me throw this at you. Think about this for a minute. What if somebody wrote down 1/5, 1 out of 5? That's wrong. But do you see what they're thinking? I get this all the time. Somebody tells me the probability of sneakers, Jeff, is 1 out of 5. What are they thinking?
If there's only 5 Snickers in the bag.
Yeah, there's 5 Snickers and they want one of them. But that doesn't take into, so that would mean that if I put 4 million Butterfinger, this probability doesn't change. Does that make any sense? None. So the bottom always has to be everything that could have happened. The number of things that could have happened. You with me? Maybe. The top will always be the number that matches what I'm looking for. And the bottom will always be the total number of things that could have happened. You see how slowly I said that? Sounds like a really good note to take. Or not. It's up to you. Got video? Yo. So what about the probability I get a Butterfinger or a Rocky Road? Become the word or. There you go, Jeff. Borer. It's like this class is totally boring. What is probability I get a Butterfinger or a Rocky Road? How many things match what I'm looking for now? 11. Yeah. So or seems to mean to do what? Add. I like it. It's going to come up again later. So or basically seems to mean add. So there's 11 things that match what I'm looking for because now I'm more open. For some reason I just hate Snickers. I want one of the other two. And of course out of 16 because it could have been any of the 16 candy bars. I like it. Anybody? Okay. Bodacious. All right. So there's only so much I could do with this simple. So let's step it up. Let's step it up. Here's the kind of problem I'd love to give you. You will see this on the quiz. You will see this on the final. You will see this a few times. Let's see. I don't know. Let's just do what I did the other day. This could get weird. Greater equal to 21. Let's do it this way. Let's do it in order. So I talked to a bunch of people. There were some that were younger than 21 and some that were at least 21. You guys with me? So far. And I asked them a question. And their answers could be yes, no, maybe. Okay. So I'm going to let you imagine what the question might have been. Okay, I like it. This is what's called a contingency table. That name is not important. But if you ever hear the phrase contingency table, it means this. Can we read this correctly? How many people are not able to drink yet legally and said no? Less than 21 and said no. 31 people are less than 21 and said no. How many people are at least 21? How many people are at least 21? Yeah, 41. So it looks like a really smart idea is to total all this shit up. So 29, 7, and 5 is 41. 5, 31, and 4, 40. 5 are 29, 31 are 7, 4 and 5. So either way you add it up, it should come out to be, so what's 40 and 41? 81. Now I do get people that add these people also, but why is that phrase I just said make no sense? If I add these people up, are these different people? Come on, you can do it. All these people and all these people, that's freaking everybody. So don't add 81 to 81. You guys with me? That is a common mistake. But this thankfully adds up to 81 also. Okay. All right. I like it. So now I can ask a ton of questions, which is exactly what I will do now. Oh, shit. I love looking out. Some of your faces are like, why? All right. Because you signed up for it. So let me ask you this. What's the probability I pick somebody who's at least 21? I think I heard it. 41 out of 81. I love being so close. Oh, thank God. Why do people still have alarms? And somebody help me out. What is that as a decimal to 4 places? We're going to take probabilities out to 4 places as a decimal because we're crazy. Got to be like 0.5, 0.4 maybe? 0.4927. I don't have a clue. What is it? I went the wrong way. Damn. 0.5061, or you can make it 50.61%. I don't care. You with me? So a little more than half of the people I talked to were able to share a drink with me legally. I like it, at least in the States. Not amazing, not, earth-shaking. So it's probably I picked somebody who said maybe. You could do it. Yikes. What is it? 9 out of 81. Which is 1/9, which is 0.1111. 1111. Why does it make sense? Because who knows? Real quick, side note. What's 1/3 as a decimal? You guys should know. 0.333333, right? You with me? Isn't 1/3 3/9? Right? And 3/9 is 0.3333. So what's 1/9? 0.1111. Woo. All right. Or just put in your calculator, whatever. All right, let's make some more interesting questions. What's the probability that somebody said yes and they are less than 21? Oh, shit. Five, yeah, good. So, all right, stay with me now, stay with me. And, technically, in mathematics at least, means one thing. It means you must meet all the requirements. Have any of you guys ever applied for scholarships? Have you ever applied? Have you ever considered? Do you know what scholarships are? Okay. Are you thinking about transferring and maybe you're going to apply for some scholarships? You should apply for every damn scholarship you can. That's what I did. And a lot of them asked for my philosophy of life, and I had a standard pat statement. I would just chuck it in there and send it off. Right? And I got 500 from here and 400 from there, and I was like, oh, sweet, maybe I could actually afford college. But my point with this is, back in the day, before the internet was really a big thing, there was a book about this big that they would update every month, and it had all the scholarships in it. So we were like killing trees like crazy. You're welcome. So, you don't need to breathe that much. So you would open it up and you look at a scholarship. You must be it would say this: you can get $20,000. Holy shit! But you must be a math major. Check. You must have at least this GPA. There. You must, blah, 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 blah. And then the very last thing, and this, and this, and this, and you must be a woman. Oh, lead with that. This is based on a true story, by the way. Several times the last statement in this big list of ands would be, you must be 50% Native American. Put that first. All right, you guys with me? So those are all and statements. So the number of things that match what goes with that decreases, right? Okay, all right. So and always makes things smaller because there's more requirements to meet. Sometimes we call and an intersection, and you can see why. What's the intersection of less than 21 and yes, 5? So it'll be 5 out of 81. The bottom will always be 81 unless I give you information about the person. Here, I don't know shit about the person. What does this come out to be? 8.063. What is it? Somebody help me out. 0.6 who? 1.7. That's pretty good, right? Come on. Let's try again, math boy. All right. So let's do an or. Let's do an or like we did earlier. Probability that somebody said no or they are at least 21. Now this is getting interesting. Think about it for a minute. Probabilities never change the idea. The number that matches what you're looking for divided by the total.
Wait, say that one more time.
What I just said?
Yeah.
Probabilities are always this, believe it or not. The number of things that match what you're looking for divided by the total things it could be. So definitely what's going to be on the bottom of this? 81, because I didn't tell you, I didn't give you information about the person. So it could have been any of the freaking 81 people. Now here's the trick, how many match what I'm looking for?
So do you have to just do 38 plus 41?
Now watch, this is the key. You with me? If you do 38, the nose, plus 41, what have you done twice? Oh, shit. If you do all the no's and all the greater than or equal to 21s, how many people have you counted twice? You can do it. If I count all these people and all these people, how many have you counted twice? The 7, right? Does that make sense? That's not fair. They don't get to vote twice. Hopefully that won't happen. Yes?
Would it just be 7?
Nope. That would be if it was and. Or is ours. You ready? Here we go. Oh, yes. Or always makes the number bigger. Because what does it take to match what I'm looking for? Now I'm being more open. Oh, this, or this, or this. You with me? So I always think of or as being the nice bouncer at this bar, right? I come up to the or bouncer and he says, all right, to get in here, you have to be rich. No. Or you have to dress nice. No. Or you got to know Joe the I know Joe. Hey, Joe. And then I can go in. Do you see what I'm saying? Or is the nice bouncer. The number always gets bigger because now more things match. What about the and bouncer? So I go to the and bar, which is a horrible name for a bar, but who gives a shit as long as they have a... So you go to the and bar, and the guy says, all right, to get in here, you got to know Joe. He works here too. I'm like, I know Joe. And you got to be rich. I'm dead. And you got to... Oh, you stop. And you got to dress nice? I don't care. I'm done. I don't meet all those requirements. And you must meet all the requirements. Or you just have to meet at least one.
So and is just like a slimmer probability?
Yes, and always decreases the chances because you have more requirements to meet. Or increases. Right? The top number gets bigger because now you're being more open to who can come in the room or in the bar or in the problem. Okay, maybe. That's some of you guys are daydreaming about a bar. It's too early. So here, it's not going to be, if you did 38 plus 41, you'd have to subtract 7. Because you would have counted them twice. And then what do you get? I don't know. 172. Plus, look what you get here real quick. What if you didn't do that? What do you get? That's not quite. It's possible. Do you see how it's possible? It doesn't quite get up to 79. But people do this and they get like 83 over 81. Why would that be a problem to get 83 over 81? It's more than frickin' 1. So you have a greater than 100% chance. What does that mean? It's going to happen in this dimension and the next one. What does that mean? Greater than 100% chance of rain. They're going to be giant raindrops. Yes?
Instead of subtracting the 7, can you just...
Totally. I love it. Kick ass. So you could be smart about this. And notice, have we developed any formula for probabilities yet?
No.
Are we calculating a bunch of probabilities? Yes. We will develop formulas. There will be times when I need to use them. When do I not need to use the formulas? When I have everything I need to count. Because that's all probabilities are, is a count. So people will get this problem, they'll try to force the formula to work, and they'll screw it up. Right? They'll screw it up. So let's see. Where am I at? What is this? This will be 8, 9, so 0.888? 9. You want to round? Which you should. So 88.89%, whatever. So you could have done this. You could have said, all right, 41 of these people. Now, how many no's have I not counted yet? 41. How many no's? I counted these no's, right? How many no's did I not count yet? So that's 72, which is exactly 11, right? Yes? I like it. So if you have all the situations to count, there will be shortcuts to get to the answer. Now right now, let's develop the formula for OR. We didn't need it, Jeff. I know, but there will be situations where we will need it. So this is kind of neat. You guys have never, well, not never, but it's never been really put in your face that that's what you were doing. We're going to develop a formula based on what we just did, and then I can use it everywhere. Because the idea of OR shouldn't really change. So if I do probability of some event A or some event B, we like to use capital letters for like variables that represent events. So A could be getting somebody less than 21. B could be getting somebody who said yes, whatever. Or it could be the probability of rain, or the probability that plane crashes. That's terrible, Jeff, but I was, but you know my room. Somebody help me out. What is this? 38 out of 81. What was that? The probability of no, right? You guys with me? 38 out of 81 is the probability of the first dude. What is 41 out of 81? Probability greater than or equal to 21. So probability of the second dude. So like I said earlier, OR is basically add, which makes sense because OR is increasing the chances to match what you're looking for. But what's this? Minus what? What is 7 out of 81? You can do it. What probability does that represent? Sorry, do it again. No. And. Yeah, it's an and. So this would be minus the probability of A and B.
Whoa.
Let me give you a visual. Have you guys ever seen a diagram like this? Do you know what this is called? Venn diagram, I love it. Okay. So if I do the probability of A plus the probability of B, you can see visually, you can see what I've counted twice. What area did I count twice? The sliver dude in the middle. What does this represent? A and B. So I got to subtract it off because I counted it twice. All right, there's a nice visual of that formula. Kick ass. Maybe. All right, all right. Continuing. We are going to develop a formula for and. We can't do it yet. And right now, with this kind of problem, I don't need a freaking formula for and. It's just where they intersect. We will need one, though, eventually. We're going to get there in a minute. Oh, shit. Do like Trump and say, oh, it's a little bit further. Pentasi. I like Pentasi. Where am I at? 5. So let me ask you, this is a different kind of question. We haven't done this kind of question yet. This is so exciting. Just contain yourselves. What's the probability that somebody said no, given that they were under 21? You can spell, Jeff. There you go, buddy. So let me read that again to you. What is the probability that they said no, given that they're under 21? So what do you know about the person? No. Let's read it again. What is the probability they said no? So do I know they said no? If I did, it'd be 100%. I'd be done. What's the probability they said no, given that they are under 21? So what do I know about the person? They're under 21. Given they're under 21. So what's going to change? If I know they're under 21, what number? The bottom is going to be changed. Does the idea of probability change? No. The bottom is still everybody it could be. But what kind of person could it be? Less than 21. So how many people are we talking about? How many? 40, yeah. So now watch. What's my universe now? Who do I throw out? Yeah, the overtime. So now there's my universe. So what's the probability that they said no? 31 out of 40. Kick ass.